Okay, hello everybody. I am Jennifer Lamberts from the Mary Lyon School, and my email is jlamberts@bostonpublicschools.org. I am going to give you a brief overview of investigations 3 through 5. So investigation 3 is pretty straightforward. Again, it's all about comparing speeds. It'll take you about 2 weeks. In this investigation, you will conduct experiments to acquire time and distance data and to determine speed. They will use a distance versus time graph to determine an object's speed. So this is, again, developing their graphing skills. And they'll continue to realize that the slope of a line on a distance versus time graph represents speed, and that steeper slopes represents higher speeds. Here, they're going to use tools to gather and organize data and solve problems. You have an opportunity to make this much more open-ended, and I'll talk a little bit about that. And they'll continue to explain speed in terms of distance and time. So investigation 3 is broken up into 3 main sections. The first one is an active experiment that the students run, and here they will determine their walking and running speeds. They love this. You will need an area that you can go outside, or maybe the gym or the cafeteria, whatever you guys have, but they really enjoy this. This will take at least a day, probably 2, to also do the graphing and the analyzing. And it also depends how open-ended you want it. You can give them the procedure, and you can give them the data sheet, or you can have them at this point in the year, especially if this is your 3rd unit, you could have them come up with their own experiment, write their own procedure, write their own data collection, and have them come up with all of their data on their own and kind of talk about pros and cons. I've done that before, which I've really liked. At the end of this part, there is actually a computer part, and I do want to show you guys again where that is. So if you go to your FOSS web resources, it's the best place, and where I am is just the resources by investigation. So I'm going to go down to investigation 3, and these are all their lab notebook sheets. So if you look at this, this is the lab notebook sheet, walk and run speeds. This is what the students would get. So you can see that you're, focusing on multiple trials. They're doing an average, and they're going to actually have to graph it. And again, they'll see the steeper the slope, the faster the speed. But they also have these things. If it has a little star, this is your photo finish, actual multimedia. So I haven't used this a ton in my classroom because I don't have computers, but if you have computers, this would be potentially a great thing to do. So they have this race, you got a bug and a robot, and this is just practicing some more skills. So maybe you can do this as a whole class activity if you needed. But I just wanted to show you where that was. The next part of the investigation 3 is the boat races. And this is, again, pretty straightforward. They are just figuring out which boat went the fastest. And then they actually have to determine which boat, if they wanted all the boats to end at the same time, what the head start would be. Again, a pretty straightforward, fun investigation. And in this, they also have a response sheet, which is another opportunity for you to collect some data and evaluate their writing. This part 3, it's called the Iditarod. It actually is something that I have skipped in years past, and I don't like to say that you need to skip anything, but the reality is you run out of time. I have used this a lot. This comes with a video, a sled dog video, which the students really like. It's about the Iditarod race, but the video is about an hour long. So I've used this when I've been out for maybe a sub activity. I haven't watched the whole video. There's also a pretty lengthy and difficult reading. And part 3 also it looks like a very simple activity, but it's pretty complicated, and the students really need to be walked through it, because they have stuff like time that's in 11 days and 15 hours, and you need to talk them through the idea that it can only be in all hours or all days. Some classes have definitely done better than other classes. But this will take you a few days. I wouldn't give the reading all in one night either. So it's an overview of Investigation 3. Investigation 4, called Representing Motion. So this is the first time that they're not just doing a single leg motion event. So at this point, they've only done average speed. And now they're finally going to start to talk about there's multiple legs for each motion event. And they'll also talk about that a horizontal line on a speed graph represents no movement. They'll come up with motion scenarios from graphic representations of motion events. And they'll also have to be able to create graphic representations from the motion scenarios. This is a great investigation. It will take you 7 sessions or 1.5 weeks at least. And another main idea is the difference between displacement and distance. So displacement, I like to connect to absolute value. It's your distance from 0. And distance can only be positive, where displacement can be positive or negative. This investigation does get tricky because they have a lot of symbols that they have to work into. So this investigation has 3 main parts. Showtime, leisurely walks, and motion stories are all very similar. I put this in here because this is something that I do for the students. This is actually the front and this is the back. I make them a bookmark. And I apologize, this isn't a great graphic to show you, but on the first page, I have the symbols for each of them. And then on the back, I have the equations for calculating speed when distance and time are known. And I have some of those key words that we talked about at first, how fast. And then I gave some examples, and how long is going to be time. And I gave some examples. So I give this to the students at this point, and they use it for the rest of the the unit. And I actually have them able to use it on tests because it's a resource. I'm more concerned that they are able to apply the concepts than are able to necessarily memorize all the equations. So I just wanted to show you what one of the lab notebook sheets look like from Investigation 4, because you'll see why it can get confusing. So here you break down this motion event. So Sue Ellen and Josie went to a show Saturday afternoon. Josie's mom drove them 5 kilometers to the show. The ride took 10 minutes. I actually have the students act this out. So they're actively engaged and we walk through it. And we talk about how there are 3 main legs: going to the movie, being at the movie, and coming home from the movie. But these 5 categories get them very confused. This, I explained to them time at the end of a leg. I explained to them that is, if I started a stopwatch and didn't end it, this is the time. The position at the end of the leg is where they would be on a ruler if it was attached to them. The time interval during the leg, the change in T, that is how much time went by for the specific specific leg. And then the displacement is for that specific leg. So for example, they went positive 5 kilometers to the show and negative 5 kilometers from the show. And then your total distance can never be negative. It can only be positive. So it would be they went 5, they didn't move, it was continued to be 5, and they came home 5, so they went a total of 10. And they have them do a position graph and then also a distance graph. And they'll see that the distance graph never goes down, the distance graph only goes up. And they have to find some data here. So you really need to take them through it a couple of times before they can do it on their own. There is enough practice for them, but I would definitely walk them through it before they really understand it. And if you're ever looking for the teacher guide, that is also on FOSS Web. And we are going to run out of time, so I will explain that in the next podcast.